All right, guys, today we're going to look at ionic compounds. And so to begin this, we'll look at our bell ringer for today. Metals tend to blank electrons, while nonmetals tend to blank electrons. And then what is an ion? So let's look at our periodic table. We look at our periodic table and we list all of the oxidation numbers. First thing we need to do is list the oxidation numbers. So 1 plus, 2 plus, 3 plus, I'm skipping. 3 minus, 2 minus, 1 minus. All right, so there's that. Next thing we need to do is we need to determine where the metals are and nonmetals. So the metals are on this side, and the nonmetals are on this side. Okay. So my metals are on the left, my nonmetals are on the right. And so metals tend to blank. If I am a metal, so I'm looking at these, I have a 3 plus. So am I gaining electrons or losing? I am losing electrons. I have more protons than electrons. I have more positives and negatives. So the answer is number 1, metals tend to lose electrons. And then my nonmetals, so notice these groups over here will be your nonmetals, okay? They're going to have a 3 minus, so they're going to tend to gain electrons. That's just how they behave. And so the last question says, what is an ion? An ion is an element with a positive or negative charge because of a difference in electrons. All right, so you're going to need to get your note sheet and go over your notes with me as we do this. So we'll partially be looking at the notes as we go through the PowerPoint. All right, next thing. So bonding. When bonds between elements are formed, a compound is going to be formed. And you need to know a compound is 2 or more elements chemically bonded together. So we're going to talk about 2 types of bonds. We'll talk about ionic and we'll also talk about covalent. Today, we're only doing ionic bonds. All right, let's go to the next one. And so the big question, are the elements metals or nonmetals? Anytime you determine what kind of bond is happening, you need to look first to see if they're metals or nonmetals. So that's right, it's really important for you to understand where the metals are, where the nonmetals are, as well as the oxidation number. All right, so let's look at our notes. Ionic bonds form from the attraction between oppositely charged ions. They're going to be created when electrons are transferred from a metal to a nonmetal. All right. And then this goes back to our problem of the day. Metals tend to lose electrons to become positive. Positively charged. And nonmetals tend to gain electrons to become negatively charged. And remember, the other terms we've talked about were cations and anions. Okay, and so we're going to look at an example of this. And so the first thing you need to look at is we need to look at a Lewis dot structure. So a Lewis dot structure, just to remind you, just shows the valence electrons. And if we recall, we want to have a full octet. So I want to have 8 valence electrons, if at all possible. And so drawing these will help show where the electrons are going. Are they gaining or are they losing electrons? And so the first one we're going to look at is we're going to look at potassium and fluorine. So let's look at potassium and fluorine. The first thing I want you to do is I want you to look at your periodic table. I'll pull mine up here. Okay, look at your periodic table. And on here, make sure you know 1 plus 2 plus 3 plus skip, 3 minus 2 minus 1 minus zip. Okay, and I'm going to draw my Lewis dot structure for potassium. So I'm going to write K. Now, K is in the first column, so it's going to have 1 valence electron. Demonstrate this with 1 valence electron. Okay. Find fluorine. Fluorine is over here. So fluorine has 7 valence electrons because it is in the 17th column. So I'm going to draw the right symbol, F. 1, 2, 3, 4, 5, 6, 7. And so are either one of these full? That's the first thing you need to ask yourself. Okay. No, they're not full. Let me go a step further. What type of element is potassium? Is it a metal or non-metal? Potassium is a metal. Fluorine is a non-metal. So I'm going to make an ionic bond. All right. In order for potassium to be full, it is going to lose this 1 electron. It's going to come over here. And now fluorine is full because if fluorine gains an electron, I've got 1, 2, 3, 4, 5, 6, 7, 8. And then the inner shell for the potassium would be full. And so that's what it's going to look like if we're looking at a Lewis dot structure. Let's look at if we were to not draw the Lewis dot structure, if we were to cancel the ionic charges. What is the oxidation number for potassium? It's in the first column. So it's going to be K1 plus. All right. Fluorine is all the way over here. So let's remember 1 plus, 2 plus, 3 plus, skip, 3 minus, 2 minus, 1 minus. So it's going to be F1 minus. All right, so you see how it says cancel ion charges? They have to balance. If I have 1 positive and 1 negative, does that balance out? It does balance out, okay? And so now the next thing we're going to do is we're going to write the chemical formula. How many Ks do I have? I have 1 K, so I'm going to write K. How many Fs do you have? You have 1 F. So your chemical formula is going to be Kf. You always write your metal, and then you write your non-metal. All right, and it says to name the formula. So let's go back to our notes and look up how to name our formula. And so this is the example, Lewis dot structure, and then you can see it kind of moving over there. Okay. Stable ionic bonds have the same number of positive and negative charges. This ionic bond is the attraction between the positive ion and the negative F ion. And then it says put the symbols together and you have the chemical formula. There are no charges in a chemical formula. So before over here, I wrote the charges. The charges are balanced so they cancel each other out. So when I write my formula, I leave them off. Okay. And so let's review this. Your oxidation number shows the charge of an ion. So what's the oxidation number? I've got Mg2 plus. What would the oxidation number be for nitrogen? If you find nitrogen, the oxidation number is 3 minus. That's why it's important to understand what we wrote on the periodic table earlier. So when we cancel this out, it says when adding the oxidation numbers of ions together to form a compound, they must equal 0. This means it is a balanced compound. And we'll do some more practice in a second. All right, so let's talk about naming. It says for the first element, which is always going to be the metal, use the full name. So in our example up here, we had, what was our first element? We had potassium. So we'll write potassium here. For the second element, you need to, which is going to be your nonmetal, change the ending to ID E. Example, fluoride. So the name of this element is potassium fluoride. Okay. So let's do a little bit more practice. Let's go back to our periodic table. So we're going to do this anytime we do ionic compounds. We're going to have to do all three things. You need to understand how to do all three things. So first one, calcium and fluorine. Let's start by drawing our Lewis dot structure. So calcium is in the second column. Calcium. Well, first thing I need to check, is this a metal and a non-metal? So calcium is on the left. So this is going to be a metal. Fluorine, we should already know, is on the right. This is going to be a non-metal. So calcium, Ca, has 2 valence electrons. Okay, and from before, fluorine is in the 17th column. So it's going to have 7 valence electrons. All right, now remember, fluorine wants to get 1. So if calcium has 2, it can give up 1 here. Now that fluorine's full. Is calcium full yet? No, because calcium still has 1 left over. So I can't take away valence electrons, but what I can do is I can add an element. Okay, I'm just going to add another fluorine. Fluorine. Remember, fluorine had 7. And so now this calcium will come here. Okay, and so let's just double check ourselves using the ions. So my metal is calcium. The oxidation number for calcium, if you look back at our periodic table, calcium is here. It is a 2+ charge. So it has a 2+ on it. Fluorine, from up here we should know, and just let's look at our periodic table, has a 1- charge. So 1-. Now, if I have 2 positives and 1 negative, are those balanced? No, they're not. Can I make them balanced? Yes, I can. Simply adding another element. So now I have 2 negatives and 1 positive. Okay, so let's go and look at our formula. The metal gets written first, Ca. The non-metal gets written second. So this tells me I have 1 calcium and 1 fluorine, but I don't have 1 fluorine, so I need to count 1, 2, and I write it as a subscript, which is below. So CaF2, meaning I have 1 calcium and 2 fluorines. Make sure if I had a 4 here, it would be calcium, fluorine together, but I would need to know that that would be 4 calciums. All right, let's name this compound. Write the metal first, calcium. And then you have a space, and you take the second element and just add I to it, fluoride. So this is calcium fluoride. It doesn't matter that there's 2 fluorines right here. It's an ionic bond, and that's how they're named. All right, let's practice a little bit more. Magnesium and oxygen. Find magnesium. Magnesium's on the left, so it is a metal. Oxygen is on the right. It is a nonmetal. So this is going to be an ionic bond. That's the most important thing. Make sure you understand if it's a metal or nonmetal. All right, so magnesium, I'm going to draw that first. It has 2 valence electrons because it's in the second column. Oxygen, oxygen is in the 16th, so it's going to have 6 valence electrons. Oxygen needs to get 2. So 1, 2. Magnesium, it's all gone there. Oxygen is all full now. Let's go and write our ions. So Mg, G, 2 plus. Oxygen, 2 minus. Are they balanced? I have 2 positives and 2 negatives. Yes, they are. And so when we write our formula, I write my metal, magnesium. How many magnesiums do I have? Just 1, not 2. The charge is 2. How many oxygens do you have? 1. So it's that. All right, why don't you pause the video and try to name it yourself. So you do your metal, magnesium. You do your non-metal, and you drop the ending and add IDE. So oxide. Okay, well, let's do one more tricky one. Aluminum and sulfur. So remember, aluminum is a metal. So let's make sure we know that this is a metal. Sulfur to the right is a non-metal. So I'm going to have an ionic bond. How many valence electrons does aluminum have? If we look at our periodic table, it has 3. So Al, 1, 2, 3. Sulfur has 6 valence electrons. 1, 2, 3, 4, 5, 6. All right, so this one's tricky. Let's see if we can do it. If you want to pause the video and try it yourself and then come back and check, you can. Aluminum loses 2 here. Okay, now sulfur's full, but there's an extra aluminum. Can't transfer, or I'm not going to transfer to another aluminum, so I'm going to draw another sulfur. And I'm not just going to draw 7 because sulfur has 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay. Now this aluminum is done. Is this sulfur full yet? No, because I still need one more. So I'm going to add an aluminum. And I'm just adding them where I want to. 1, 2, 3, 4, 5, 6. But that's not how many. Aluminum, don't forget, aluminum has 3 valence electrons. So I messed that up a little bit. 1, 2, 3. This one goes here. Okay, so these 2 sulfurs are now full. This aluminum's done. This aluminum still has 2 left. So what can I do? I'm going to add another sulfur. Sulfur has 6 valence electrons. This aluminum can come here. This one can come here. And now all my valence electrons are accounted for. Okay, so let's go and do the ions. Aluminum has a 3 plus charge. Sulfur has a 2 minus charge. All right, now, are these balanced? No, they're not. I've got to figure out a way to balance them. I know that I think things through, okay, I can't make a 3 into a 2, I can't make a 2 into a 3, but I can make them both into 6, so let's check. Al3 plus, S2 minus. I've got 6 here and I only have 4 here. Can I make this 4 into a 6? I can. S2 minus. Now I've got 2 aluminums, which is how many I had over here. So these 2 should match. And I have 1, 2, 3 sulfurs. 1, 2, 3 sulfurs. 6 positives, 6 negatives. Okay, let's write our chemical formula. So I do metals first. How many aluminums did we have? 1, 2. So Al2. How many sulfurs? 1, 2, 3. S3. Okay, so we'll name it, and this would be metal. And then we do our non-metal and add IDE, sulfide. Aluminum sulfide is your answer. All right. So I will have a part 2 of this video to come back and show you how I did these. If you want to try these on your own, then you can do that. And don't forget that you need to make sure that you do the back of this worksheet. And that's what's going to count for part of your grade. So come back and watch part 2.